Hello everyone, welcome back. So today we're going to be talking about quadratic equations. So we'll start out by writing the most well-known form of the quadratic equation, and that's going to be ax squared plus bx plus c equals 0. And this is called the standard form because it's pretty standard polynomial notation. The second form is the factored form, where we have a times x minus p times x minus q equals 0. This is called the factored form. Now, this form has an advantage in that p, q are the roots. So it's very easy to see the roots or to find them if you have a quadratic equation in this form. The last form is the vertex form. So that looks something like a times x minus b plus h, and this is squared here, equals 0. So this is called the vertex form. And this is usually useful when we're trying to graph quadratic equations, because when you're in this form, the point BH is the vertex of the quadratic equation. And from that, it's much easier to actually draw the diagram out. So next, let's go over a little bit about the fundamentals of quadratic equations. Well, fundamentally, right, let's say you have a quadratic equation. This can only have two roots. And it can have one, or it can have no, or two real roots, I should say. Or two roots in general, but they can be real or complex. But if you have a quadratic equation, it's impossible for it to have more than two roots. They could be identical roots, in which it would be one root, but technically we call that a double root. Now, the quadratic equation, usually at this point, assuming we haven't covered complex numbers yet, and this video will be made mostly on the reals, some quadratic equations won't have a root. Now, as you can see, if I were to draw the graph of, let's say, just a random quadratic equation, right? If that was the y-axis, this is the x-axis, and this is obviously the point 0, 0, right smack in the middle there. If the quadratic looked something like this, then yes, there would indeed be two roots. There would be one here and one here, right? But instead, if the quadratic looked something like this, we can see that this is not going to cut the line x equals 0 or y equals 0 at any point. And therefore, there's no roots in this case, or no real roots, I should say. There are imaginary roots or complex roots. Now, how do we go about solving quadratic equations? Well, let's say we are given a random quadratic equation. X squared plus 10x plus 24 equals 0. Okay, so when we see a quadratic equation like this, you might have already learned from previous IB classes, or maybe from before IB, that you should always try to factor. Factoring is usually the easiest way and the quickest way to find roots of a quadratic equation, where you don't actually have to plug in the whole formula for the quadratic equation. So in this case, remember, we're trying to find a sum of the numbers that sum to 10, right? So a plus b equals 10, and a times b equals 24. Now, obviously, you might have learned to solve this or try to find the factors a different way, but in this case, it's not too hard to see that a pair of roots should be 4, 6, right? So therefore, the factored form should be x minus 4, or x plus 4, times x plus 6. equals 0. In which case, either one of the factors has to be 0 for this equation to stand, and therefore the roots would be -4 and -6. So, in general, when you see a quadratic equation, try to find the factors. Now, obviously, this gets harder as the numbers gets bigger. So, we'll discuss other ways right now. Okay, so now let's say you're faced with another quadratic equation, x squared plus 4x plus or minus 7 equals 0. How do we go about solving this? You can try to factor, but as you can quickly find out, there's no real good way of finding the factors, and it's very hard to find them because the answers, they're not integers, and you can't really use the rational root theorem here to find any of the roots. So what do we do here? Well, let's go back to the drawing board where we had ax squared plus bx plus c equals 0. Now, those of you that have learned the quadratic equation would just say, yeah, let's plug it into the quadratic equation. And that's going to be x equals -b plus minus the square root of b squared minus 4ac all over 2a. But I think what's more important here is to fully understand how this formula was derived. And really, it's not that complicated. So if you want to stick around, I'll go through the full proof right now, the derivation, but if you want to skip ahead to just solving the problem, I'll leave a timestamp in the description below and you can just click on that. But for now, let's try to derive the quadratic equation formula. So the formula comes from completing the square. Basically, we want to write our quadratic equation here into a perfect square so that we can square root both sides, and then we'll have a linear equation to solve, which we know how to solve. But the problem we have right now is that this is not very clean to be square rooted, and we don't really know what square rooting this would be like. So first of all, our goal is to eliminate the factor a here, right? Because if we were to square root something, it's best that the coefficient of the x squared term here is 1, because we know that x plus something squared would have a coefficient of 1 in front of the x squared. So with that in mind, we're going to divide a throughout the equation. So we have x squared plus b over ax plus c over a equal 0. Great. So now we have our coefficient of 1 in the x squared term. Now we want to be able to complete the square. So that means, remember that when we square something, let's say we square x plus y squared, we have x squared plus 2xy plus y squared. So we want to somehow mold this into this form. Now, x squared is already here. That's great. And we have an x here, which matches this thing. So that means b over a must be 2y. So if we let b over a equal 2y, we can get that y is equal to b over 2a. And therefore, y squared would be b squared over 4a squared. So in order to complete the square here, we're going to add this term on both sides of the equation and move this to the right hand side. And we will be left with x squared plus b over ax. So the first two terms stay the same. We're going to add b squared over 4a squared on both sides of the equation. So b squared over 4a squared. And then remember, we moved c over a on this side. So we get minus c over a. Now we know how to complete the square on this side, right? This is already completed. So we know that this is going to be x plus b over 2a squared. And on the right hand side, we can change them to have the same denominator, and that would be b squared minus 4ac over 2, or 4a squared. Okay, so I just went ahead and cleared some of the space so we have more room. Now remember, we were left with x plus b over 2a squared equals b squared minus 4ac over 4a squared. So now we can go ahead and square root both sides, because now this is a perfect square, which is exactly what we want. So after square rooting both sides, we get x plus b over 2a equals plus or minus the square root of b squared minus 4ac over 4a squared. Remember the positive negative here, because x plus b over 2a could be both the positive root or the negative root. So that gives plus minus, we can take the 4a squared out of the square root, 2a over square root of b squared minus 4ac. Then we can move this to the right hand side, and we're left with x equals negative b over 2a plus minus square root of b squared minus 4ac over 2a, which is equal to 2a negative b plus minus square root of b squared minus 4ac. So that is the full derivation. I hope this is clear, and I explained the thought process of this derivation as well. But of course, if you have any questions, feel free to leave it in the comment below. Now, let's take a look at this formula that we just derived. Are there any limitations to this formula? Well, first of all, we can see that there's a fraction, and whenever there's a fraction, we know that the denominator can't be 0. So that means that a should not be 0. And if we look at our quadratic equation here, indeed, a shouldn't be 0, because if it is, it would just be a linear equation, and we wouldn't have to go through this process at all. So that's kind of irrelevant. But the other thing is the square root here. Now, as we know, we can't square root negative numbers without dealing with complex numbers yet. So that means that b squared minus 4ac must be greater than or equal to 0 for this quadratic equation to have real roots. Okay, now let's take a deeper look into the quadratic formula. So the quadratic formula states that x equals negative b plus minus the square root of b squared, b squared minus 4ac all over 2a. So now remember, 2a being in the denominator is not a problem if we look at the standard form of a quadratic equation. However, we have to make sure that b squared minus 4ac must be greater than or equal to 0 for this quadratic equation to have real roots. So that means that if this is smaller than 0, we can get that this quadratic equation has no real roots. Also, we can actually go one step farther and say that if b squared minus 4ac equals 0, which is 0 here, and therefore the square root of 0 is still 0, and plus minus 0 doesn't change anything. So this whole thing is just gone. And therefore the roots are just, or the root in this case, singular, is just negative b over 2a. One real root. or in this case, we call it a double root. And finally, if b squared minus 4ac is greater than 0, then there are two real roots. Now, because of how important this value of b squared minus 4ac is to the quadratic equation, we gave it a special name and a special symbol. It looks like this, like a triangle, and we call it the discriminant. Now this is the Greek symbol delta. So you can also say the delta, but the discriminant is very important to a quadratic equation because we can determine if it will have real roots, a real root, or no real roots just by looking at the coefficient of the quadratic equation. So that's pretty much it for this video. Next video, we'll do some more practice questions with the quadratic equations. But for this video, I hope you learned something. If you did, please leave a like and subscribe. It really helps out the channel, and it helps out to bring more videos like this out to you guys. So, thank you everyone for watching, and I'll see you in the next one.